Uh, so we're going to be focusing on student learning and the impact of teaching out of field on student learning. So there are a number of studies that have been done in different contexts looking at student learning and how students learn less when they're being taught out of field. The issue, as the way that we have been looking at it is that students who are teachers who are teaching students are doing so based on a curriculum that they have within their context. And that's oftentimes different from the exams or assessments that are used to determine whether or not students are learning more or less. So the assessment being used to assess student learning is not directly aligned to the curriculum that the students and teachers are supposed to be learning. So we have been working in, try again. I did a study that was published in the edited volume that Linda and Rafaela did that was focused on secondary maths, and there it is. In this case, the test was aligned with the curriculum being taught. So we had secondary math students in grades 7, 8, and 9 who were being taught math. The assessment used to evaluate student learning was directly aligned with what the teachers were supposed to be teaching. And we found that students learned the least when they were taught out of field. And they learned the most when the teachers were actually prepared to teach secondary math and were teaching secondary math. There were some limitations of this study. One was that we only considered years of teaching experience, not years teaching in the different grades, so a teacher who got prepared to teach, let's say, English, but then took a licensure test to teach math, they could have been teaching English for 10 years and math for 1 year. We didn't consider those differences in that original study. We included interns who were still in training. These are teachers who are teacher of record, but they're still in a teacher preparation program. And we treated them as a member of the out of field group, which in some respects led to the out of field group being and the way we were looking at it, it wasn't a true out of field group because they're still in training, but they could have some training in the maths area. And it didn't consider the idea that teaching a course out of field may benefit student learning over time. So somebody who's teaching out of field maths, but they've been doing it for 5 years may have a different characteristic than somebody who's teaching it for the very first time. So, and then the state released new data. And it was really interesting because the new data actually had over 600,000 teacher licenses that were missing from the prior years. So we had potentially recorded teachers as teaching out of field because we didn't have the data that actually existed. So this new study is going to be following up on the old study, but by taking into consideration these other factors. So our research questions are, does teaching out of field result in less learning in English and in math? So the work that Minda and I have been doing have been focused on secondary English, in addition to following up the secondary math. We also want to look at teacher preparation and the subject of the teacher preparation. So in Texas, teachers are prepared, they have a specific license, a specific subject that they're prepared in the secondary field areas. And then what we calculated was how many years it takes of experience. So a teacher gaining experience in teaching out of field, how many years does it take to eliminate this negative effect of teaching out of field? So just to give people a sense, I know some of you last year have heard this, but those of you who are new, the data set that we are using is massive. It's got over 30 years of student and teacher data. In Texas, we have 5.4 million elementary, primary and secondary students enrolled in public education every year. So 30 years times 5.4 million is roughly the size of the student population that we're looking at. We have 340,000 teachers annually. We have workforce and higher ed, college and university data that we have access to. The student data includes student enrollment, different kinds of services received. So if they're emerging bilinguals, receiving special education services, we have data to link students to teachers in particular classes. And that data set, that single data set alone has over 500 million records in it. Very detailed about when the class met, how the student did grade-wise, and if the teacher would taught for the first couple of months and then a switch to another teacher, we also know that. We also have all of the state assessment data for all the standardized tests that are given in English, math, science, and history. And it's also, all of the assessments are directly linked to the curricula that the teachers are supposed to be teaching. The teacher data we have is complete educator licensure history and licensure test data. So the teachers are licensed by the state, and a teacher can hold more than one license. They are required to complete a teacher preparation program for their initial teacher education license, but then they can take a test to acquire additional licenses. Whether they were prepared for a subject or they took a test for that subject, if they hold a particular license for the class they're teaching, then legally they're considered to be teaching in field. We have over 90 pages of rules about who is teaching in field versus out of field. So in our context, it's relatively straightforward. If you're teaching secondary math, there's 8 or 10 different licenses that you can hold. If you hold one of those, you're in field. If you don't, you're out of field. So for this study, we created 4 different licensure groups that we're going to talk about. The teacher preparation program, TPP is teacher preparation program, or ITE, I've heard yesterday, where a person has completed a teacher preparation program for math in secondary grades 7 through 12. This can be an undergraduate program, it can be a master's-based program, and it can be a non-degree-based post-baccalaureate program. All 3 kinds of programs will lead to teacher preparation. In addition to completing the teacher preparation program, they also have to complete a licensure test, which is both content knowledge and pedagogical content knowledge, so CK and PCK. If they're teaching math 7-12 with that license, they're considered in field. Okay, and then there's also the test license group. So these are people who completed a teacher preparation program for a subject other than, for example, math. But they went, and after they got their first license, they went and took and prepared for and passed a licensure test for math. So they hold their initial license in English, and they went and got licensed to teach math by passing a test that shows the CK and PCK for math. And so in this case, the teaching experience that they have, they could have been teaching their original subject for several years, and then they take the test later, and now they're teaching for the first time in their new subject. We wanted to take that into consideration. The out-of-field license group is they completed teacher preparation in a subject or grade other than math 7-12, and they have not passed a math test. So they've gone through a complete teacher preparation program, but they haven't passed a test demonstrating proficiency in math 7-12. So these are the only people we're considering in the out-of-field group, is people who are fully prepared to be teachers, but didn't take the test. So they're similar to the test licensing group. Both of them were prepared for a subject other than math, but one prepared for and passed the test, and one did not. Okay. And then there's a fourth group that we're looking at, which are the intern licenses. These are people who are still enrolled in a teacher preparation program. They have not complete, we just lost lights. They have not completed a teacher preparation program yet. They are teaching math 712. They're considered in-field under state law. They may not have taken the math test yet. So they haven't completed the teacher preparation program. They're not guaranteed to have completed the math test, but they are teaching math as the official teacher of record. So those are the four groups of teachers that we created. The statistical methodology is we are using a three-level hierarchical linear modeling or value-added modeling, where students are at level 1, teachers are at level 2, and schools are at level 3. We account for the different teacher groups that they're in. We account for teaching experience in any field and teaching experience within the particular course of study that we're examining. So we're going to be looking at four different grades in English and 3 different grades in math. We looked at, like, for grade 8 math, we looked at the number of years that teachers had actually taught grade 8 math in these analyses. We're accounting for student demographic characteristics and prior performance on the state assessment. So if we're looking at grade 8 performance to see how the students are doing in the current year, we also included grade 7 math performance to equate them on prior performance. And then we accounted for differences among schools, urban, suburban, rural, and characteristics of the student body. So the percentage of students who were economically disadvantaged on the campus and characteristics like that. So just to give you a sense of the sample sizes, we did 7 different analyses. The grade 10 English analysis had almost 1.7 million students. These are unique students who have taken grade 10 English. You can see the size of the data. We have access to an enormous amount of data here. So one of the first things we wanted to look at was the years of teaching experience versus the years of experience teaching the particular course. We were concerned that there might be a lot of overlap and a really high correlation. There was not. It was a moderate correlation of 0.4, which means that the years of experience and the years of teaching the particular course are actually, there's not a straight alignment between the two. So it was important for us in all of our statistical models. There was only this slight overlap in the data. So it was important to include both of these variables. So they were tapping into different underlying characteristics of the teacher. So we found the out-of-field teaching deficit. For English, Minda is going to be presenting at ESER on Thursday. I've got a slide at the end that will give you more information about that. She'll be presenting on the English-specific results. But in general, what we found was that the teacher preparation licensed teachers were by far the most effective teachers, similar to what we have found in all of our other analyses. Similar to what we found, the out-of-field licensed teachers, so these are teachers who completed the teacher preparation program but hadn't passed the test, were the least effective teachers. And the test licensed teachers were intermediate. Okay, so even though the state found 600,000 records that had been missing, we got exactly the same pattern of results that we published in the past. So this is across all 7 of the different subjects. The same pattern was found. Out of field results in the least amount of student learning of any of the groups that we're looking at. Okay, so what we wanted to do is characterize the deficit. How do we understand this deficit of teaching out of field, and how much experience does somebody have to have teaching out of field to eliminate that deficit? So there were a lot of conversation yesterday about somebody who's been teaching out of field for 5 or more years and how they feel about whether or not they're a maths teacher What we wanted to do was look at it quantitatively and figure out how many years does somebody have to have in order to eliminate that deficit of teaching out of field. And the way we did that is we took the coefficients from the HLM, the hierarchical linear modeling. We took the coefficients for the out of field and we divided it by the experience teaching plus experience teaching that course. And that's how we calculated the years to overcome the out of field deficit. Okay. And what we found was for English, it takes 29.1 years for grade 10 English to overcome the deficit of teaching English grade 10 out of field. And this is in comparison to a first-year teacher who went through a teacher preparation program for secondary English. So to be as effective as a first-year English teacher prepared to teach secondary English, it will take 29 years for somebody who went through a teacher preparation program for a different subject to get as effective as that first-year teacher. This blew our minds when we first saw these data. We thought we've got to be doing something wrong, but the patterns are consistent. Well, you'll see it over and over again. So it takes 12 years of experience teaching grade 9 English to overcome the deficit. Okay. So this is the out of field group relative to brand new teachers in the TPP group. So they were prepared to teach secondary English. So then we look at the test licensure group. So these are people that are very similar to the out of field license group. They both have completed teacher preparation program for a subject other than English, but the test group prepared for and passed a licensure test of content knowledge and pedagogical content knowledge. And you can see what the effect is of that test. The preparation and the passing of that test had profound impact on grade 10, reducing the deficit by 18 years. So it's improving the effectiveness of the teacher dramatically to prepare for and pass the licensure test. And you can see the patterns the same. In every case, preparing for and passing the licensure test resulted in better student achievement. For the intern license, we see a similar variance across some of the years, but still a dramatic difference in the effectiveness. In every case, these three different groups of teachers were less effective than teachers prepared to teach secondary English. Secondary math, here's what it is, the deficit for teaching out of field in secondary math. Again, over 20 years for two of the grades. Test-based license, and then the intern license. So in again, every case, the teachers who were prepared to teach secondary, in this case, secondary math, are much more effective than all of the other groups who are either in the teacher preparation program or who were prepared for a different subject. So the policy implications that we see here is that the teaching general abilities of classroom management and lesson planning seem less important than the course-specific characteristics of content knowledge and pedagogical content knowledge. Because all of these people have had classroom management and lesson planning. What varies among the different groups is the CK and the PCK. The subject-specific teacher preparation groups were the most effective by far of any of the groups of teachers that we looked at. Preparing for and passing the licensure test greatly reduces the deficit of out-of-field teaching. So there's something about the preparation and the taking of that test, passing of the test that benefits their students. And then professional learning or professional development should be course specific and tailored to the content knowledge and pedagogical content knowledge of the teachers based on the different types of licensure that they hold. Because if they pass the test, they have a different level of CK and PCK than somebody who hasn't done that yet. So we are in the process of looking at different levels of professional development based on the licensure that the teacher holds. And then here are our talks. I'll be talking on Wednesday. Minda will be talking on Thursday about teaching out of fields.